All right, let's cover your homework today. We're going to look at the first problem. I'm going to do the 6 problems on the practice that I have given you in Google Classroom. If you do it first, then you can kind of get the idea, then you'll do the quiz after that. If you want to pull up the quiz while I'm doing this, you can, but I am not going to go over all of the questions. One of the things that you might note that might help you for the remainder of the quiz is to determine these things. First off, if you have a negative force, then your answer is going to be attractive force. If you have a positive force, your answer is repulsive. So that means it's repelling. If it's positive, it's negative. It will be attractive force. The next thing you're going to need to know is the charge of an electron. Electrons charged are 1.6 times 10. Again, that was 1.6, negative 1.6 times 10 to the negative 19th. So it wants to know, if it wants to know the number of electrons that have been pulled off, you take the charge that you're given and divide by the number, the charge of one electron, and that should give you the number of electrons that are given. Those are some of the things that you might be asked in the quiz. Hopefully you got the number of electron from the notes slide before you went ahead and jumped into this quiz video. But again, I'll give it to you one more time. The charge of an electron or a proton is both 1.6 times 10 to the negative 19th coulombs. If it's an electron, it's a negative 1.6 times 10 to the negative 19th coulombs, and if it's a proton, it's a positive 1.6 times 10 to the negative 19th coulombs. Hopefully you're able to get those things. Remember, if you don't get them, you can always go back to the other videos, tutorials that I went over, the notes to get that information. It's recommended that you do the notes, then the practice, then the quiz. Hopefully that makes sense. All right, from there, we're going to go ahead and get started and go into the practice. So you have this set up. I have gone ahead and set out our charges in red here for us. We are told that it's a negative 6.0 microcoulombs. Don't forget that microcoulombs means this times 10 to the negative 6th can kind of help us there. So we literally have values of negative 6.0 e negative 6 or negative 6.0 times 10 to the negative 6. They are the same thing. Don't forget that we will need our constant when we plug it into the equation, and we'll go ahead and get started from there. If you remember back from the video I did over the lecture of practice, we will find that the force electric is equal to K times Q1 times Q2 divided by R squared. All right, we see here that I went ahead and entered in all the numbers that we were given. I make a note that here these charges were not, we didn't use the microcoulombs, we used the coulombs. And don't forget, if you're given microcoulombs, you've got to convert it. It has to be times 10 to the negative 6. So whatever number you're given, if it's negative 6, then it would be negative 6 times 10 to the negative 6. Or if it's 6, it would be 6 times 10 to the negative 6, or e negative 6. Those values go in here. Your constant, which was up here, goes right here. Okay, now let's talk about why I chose to put 0.04 meters instead of 4 centimeters. Why did I do that? Well, when we're looking at Coulomb's law, you can look at the constant too if it helps. Right in here you see a meter squared. That means that the radius has to be in meters. You cannot use centimeters, so I divided by 100. 4.0 centimeters divided by 100. And that got me this information. Next, what we are going to do is go ahead and get the answer. All right, you should see your answer here now is negative 2.02.22 newtons. The negative here, this guy right here means that it is an attractive force. So if you're ever asked, okay, is this force attractive or repulsive? If it's a negative answer, then it would be attractive. If it is a positive answer, it would be a repulsive. All right, we're going to go ahead and move on. I'm going to let you do the practice number 2 on your own. It'll have the answer for you at the very last bit right down here. So if you look, I'll go ahead and do it in dark blue here, right in here. It'll give you the answer at the last bit of the problem. So make sure you can get that. Next, we're going to move on to the one that is a 4-part question. All right, so now on this slide we're going to be looking at the one. This is part 1 of 4. We're going to be going over each individual problem, and then that should finish you up and get you through the quiz. All right, so when we see this problem, the first thing I wrote down was the charges and the charges here and the distance between the two. Now, there is something I need to make sure you're paying attention to. You have 0.7 right here, positive 7 microcoulombs. That's not what I wrote here. It's because we have to be in coulombs. So every time you see 7 microcoulombs, you write down 7 times 10 to the negative 6 coulombs. You have negative 3.2 microcoulombs. We write 3.2 times 10 to the negative 6 coulombs. That should get you there. Now on the radius or the distance between the two, it was not in centimeters like the last problem, so we can use it as meters and we plug it in there. Now we're going to go ahead and do the math. Alright, so I kind of set up the equation based upon what you see here. I'm going to go ahead and zoom in over this way real quick so you see that my constant is 8.98755 times 10 to the 9th newtons. Okay. Now from there, what we're going to do is we are going to zoom back out. We also see the charges there of 7 times 10 to the negative 6 and the red charge of negative 3.2 times 10 to the negative 6. Our R is 0.22 meters. So we found those. We're going to plug those into the equation, and this is what you see here. If you would note, whenever you get done with the math, it does tell you the correct answer in the practice, but it should be, alright, so you should see here that we have a magnitude of 4.1594 newtons if we did an absolute value there. However, what you'll also note of that is that because this guy is an absolute value, we're looking at the absolute, it says the magnitude only, it did not ask you for the direction. So please make sure you pay attention to that in your quiz problem. If you bring up the question, it says magnitude only, or only what is the magnitude, so that means we do not have a direction. So when we get our answer of 4.1594 times 10 to the newtons, it will not be negative. However, the next question asks you, is the force attractive or repulsive? And because it should be negative, it's a positive charge and a negative charge. These two guys here, if you look, let me get you some yellows. These two guys here are attractive. So your answer to part 2 would be attractive. Okay, let's move on to part 3. Alright, so the remaining part of this is going to be dealing with the electrons. Remember I mentioned that at the beginning of this video. What we need to make sure we understand is we're using a specific charge that is for every electron. And we're going to take the number of electrons, or a number of the charge, and divide by the number in one electron. So we want to figure out the number of electrons, so please make sure you're paying attention, and we will go from there. Alright, this is the charge of an electron, negative 1.6 times 10 to the negative 19th coulombs. It wants to know what is how many excess electrons are on the negative quark? So we have to look at the charge. You have an excess charge of positive, and this is negative. So we'll be looking at this. The first one we'll look at, because we're doing blue, we're looking at the negative quark, so it would be this guy here, and we're going to use that information here to help us. Then for the next one, it says how many electrons has the positive quark lost. So we're going to look here, we're going to plug him in this way, and we're going to use that with the same variable of negative 1.6 times 10 to the negative 19th to help us solve for our answers. Alright, solving for the excess of negative electrons to see how many we have there. We're going to start with the charge of negative 3.2 times 10 to the negative 6 coulombs. Don't forget that this is in microcoulombs, so we've got to convert. Then we're going to divide that by how many are in, what's the charge of 1? 10 to the negative 19th. Coulombs, and then we should get an answer. When you do that math, you should get 2 times 10 to the 13th. It looks like they have 1.999994 times 10 to the 13th as the correct answer for number 3, or part 3 of 4. Now let's do the next one. It'll be done in red, so let me go ahead and minimize this one and this one. We'll minimize these guys here so we don't get confused. Let's try to make them circle the same thing. Okay. And that's the answer there. I'm going to go ahead and do the red side over here. We had a positive 7.0 times 10 to the negative 6 coulombs, and we're going to divide that by 1, negative 1.6. Remember, it's a positive charge, so we can go ahead and make that positive because that way we don't get a negative. It is how many electrons have been lost, so you would get a negative answer there because that's how many has been lost, but it's just magnitude only. So we got times 10 to the negative 19th. And we'll go from there. Hold on just a moment. And it looks like your answer should be 4.375 times 10 to the 13th. All right, that should wrap it up. Make sure you do your quiz. If you have any questions, don't hesitate to email me. As always, it helps you to try your quiz and your homework rather than just to leave it blank.